All right, let's dispatch here problems 2 and 3, which are very similar. They're very different problems, but their solution technique is very similar to that in problem 1. So I'm just going to run through these very quickly. Let me read problem 2. It says, are low-fat diets or low-carb diets more effective for weight loss? A sample of 70 subjects, and I'm going to call that sample 1, went on a low carbohydrate diet for 6 months. At the end of that time, the sample mean weight loss was 10.5 pounds with a sample standard deviation of 7.09 pounds. A second sample, calling that 2, of 76 subjects went on a low-fat diet. Their sample mean loss was 18 with a standard deviation of 7.62. Can you conclude that the mean weight loss differed between the two diets? So we've got two different samples from two different populations. Yeah, populations are the carbohydrate dieters versus the low-fat dieters. Okay, and we're asking if those mean weight losses are the same or are they different. And if we read through that again, God forbid, we'd find that there's no information about the population standard deviations. There is only information about the sample standard deviation. So the type of problem we're doing is associated with two means with independent populations. Sigma 1 and sigma 2 are not known. That goes just like the problem 1, with the exception that in this case we approximate the population standard deviations with the sample standard deviation, and we use the student t distribution, and the calculator takes care of that when you use the 2 sample t-test. All right, so what's the null? The null is that mu1 is equal to mu2, or mu1 minus mu2 is equal to 0. And what's h1? I had told you really to start with h1, so let's do that. Can you conclude that the mean weight loss differed? That just means mu1 minus mu2 does not equal 0. So we've got a two-tailed test, 2 sample test. I'm picking up the calculator right now. I know you can't see me doing that, but I'm doing it. I just turned it on. I'm going to stat. I'm going across to tests. I'm going down to item number 4, which is 2 sample t-tests. And then it asks me data or stats. The answer is stats. And it asks what is x1? And x1 bar, that's the mean of the first population. That was, looking back, 10.5 pounds. All right, 10.5 pounds, so I put in 10.5. I'm going down to what was the standard deviation. That was, it was it was 7.09. Standard deviation 7.09, and there was 70 subjects in that sample. Let me do the same thing. I'm going to put in x bar 2, sx2, and n2, and those numbers are 18. Standard deviation is 7.26, and then n2, the sample size was 76. And this is a 2 sample test, so I'm going to click on not equals U2. Which I did not do. I'm going to skip past pooled, which is set to no, and I'm going to calculate. And when I do so, first thing I'm going to look at is P, and P is 3.2 times 10 to the minus 9, a teeny number, very far into the critic region, much less than alpha, which is 0.05. And so the conclusion is reject the null. The evidence is consistent with the results of the 2 diets being different. Okay, and if we just look right above that, again, the requirements here were that the 2 samples were independent and they were simple random samples. But we just have to assume that's the case because it was not explicitly stated in the problem statement. So that was very much like problem 1, and I'm now going to skip the page here and read off problem 3. I'm actually going to skip the page and I'm actually going to stop right here. All right, thanks.